On this page, we'll revisit an old example, but now we'll look at it through a new lens now that we have a lot more knowledge behind us. So we're going to look at comparing distributions with side-by-side box plots. On this page, we're going to use box plots to compare two distributions. This is an example that we've seen before. We'll see down below. And we'll focus on how to use box plots to determine if two distributions are similar or if they're substantially different, and how to write a comparison using the 5-number summary to compare and contrast the shape, center, and spread of the distributions. So here, there's a video below here that you can watch. It's a little over 7 minutes long, but it's about using box plots to compare distributions. It compares and contrasts distributions using box plots. Yeah, it's a good one to watch. So I definitely do that. I'll try to keep it short so that you have 2 shorter videos to watch now. But here we are. Okay. Now we'll work on writing a paragraph that compares distributions. This is an example we've seen before about, well, part of it, the ages of actresses. So here we're going to compare the age distribution of ages for Best Actor and / Actress Oscar winners for the years 1929 to 2019. So a 90-year range. So notice you have actors in the top and actresses on the bottom. So if you kind of notice the boxes, the blue boxes represent where the 2 inner quartiles are for the actors or actresses. Definitely the 2 boxes are to the right more, they're further to the right in the actors versus the actresses, which means most of the actors that win Best Actor are older than those who win Best Actress. So in order to win Best Actress, you're going to be younger than someone who wins Best Actor. So, let's see, they have a little box here representing the data. So we have n is 92. So remember, n is the number of data values. That should be probably written somewhere in your notes. If not, it might be good to write it down. The minimum value. So for actors, the youngest actor to win Best Actor award was 21. For actress, sorry. The youngest actress was 21. The youngest actor was 29. The quartile 1 ends much sooner for actresses. They ended at 28.5 years old for actors, 37.5, and on. And then the maximum age, so that maximum age, though, for actresses was much higher. An 80-year-old woman won Best Actress, but a 76-year-old man won Best Actor. That was the oldest. So for the most part, I'd say the ages are, women have to be younger to win Best Actress, but not always, because the highest age was 80 versus the highest age for men was 76. So it's possible, but not as likely, I guess, that you would win if you're an older woman versus an older man. So now we'll kind of just write our observations down here based on those shape. For both men and women, the distribution of ages is skewed to the right because the upper half of the data has more variability than the lower half. This is due to older actresses and actors who are outliers. Yeah, the 80-year-old actress who won Best Actress is definitely an outlier. And the 76-year-old man who won Best Actor. In both cases, the shape suggests that fewer older actresses and actors win the Oscars for Best Acting. Center. Actresses tend to win Oscars at a younger age than actors do. The median age for actresses, 33, is lower than that for actors, 42, but not too far apart, I guess, 9 years apart, and quite a bit lower because it is also less than Q1 for actors. Yeah, okay. Spread. The actresses have more variability in their overall range, or overall ages. The range is 59 years compared to the actors' range, which is 47. But the variability in the middle half, each distribution is similar. The actresses' ages have an interquartile range of 12.5 years. The actors have an interquartile range of 11.5 years, so fairly similar. Intervals of ages for the middle half of each distribution overlap. Typical ages for actors range from 37.5 to 49 years, compared to 28.5 to 41 years for actresses. This overlap is largely due to the 3rd quartile for actresses overlapping the 2nd quartile for actors. So these are good descriptions, even if you couldn't see the box plot above. You can kind of imagine it, if you knew a lot about statistics, I guess. The 1st quartile mark for actresses is almost equal to the minimum age for actors, which means that about 25% of the winning actresses were younger than the youngest winning actor. Outliers. We see that we have outliers in both distributions. There's only one high outlier in the actors distribution compared with 6 high outliers in the actresses distribution. Now let's pull these observations together into a paragraph and compare the two distributions. So we're gonna in this paragraph, it's gonna be argued that actresses tend to win Oscars for best acting at younger ages than actors, which I bet we can all agree that it seems that way from the data. But okay, here's our paragraph. It says, in general, actresses win the best actress Oscar at younger ages than actors. The median age for actresses is 33, lower than the median for actors, 42, and lower than the first quartile mark for actors, 37.5. There's some overlap in the middle half of each distribution, which can be interpreted as representing typical winning ages. Typical actors win this Oscar between the ages of 37.5 and 49, compared to typical actresses who are between the ages of 28.5 and 41. For both sexes, the typical winning ages are similarly consistent, as seen by a comparison of the interquartile ranges. The actresses' interquartile range is 12.5, the actors is 11.5. Despite this overlap and the similar spread in the middle half of the distributions, it's important to note that about 25% of the winning actresses are younger than the youngest winning actor. Though winning actresses are arguably younger than winning actors, both distributions have older winners that are outliers. These older winners are unusual and skew the distribution of ages to the right.